Hey guys, this is 4.6, Choosing a Method, Part 2. So we've already done a choose a method, but that was before we figured out the quadratic formula. Plus I feel like this is a good end to kind of review all the types of methods that we've covered. Okay? So on your test, you're going to be asked to do, to solve problems. Some of the problems you're going to be asked to do it certain ways. So there'll be a problem that will be like solve by factoring. And then you'll have one that will say solve using complete the square. And then solve using the quadratic formula. And then you will also have maybe 3 or 4 where you'll just be able to choose which method. And you could do the same method. I mean, like if you like the quadratic formula, bam, you could just do quadratic formula for all of them. Again, they might take more time or you might run into mistakes, but that always works, right? So today we're going to be just reviewing like when these things can work, which methods can we use in certain situations. All right, so first off, factoring. Again, this is kind of the same. I guess maybe, I don't know, I'm just probably going to come back to this one really quick. Where was that? Past it. Right here. Okay, I'm just going to copy this because nothing changes for these 3 that we covered last time. This will just save us some time. So I'm going to paste that. Okay, so factoring. Factoring works great if you can find the 2 things that multiply and add. Okay, and again, just a reminder that if it takes you more than 60 seconds, chances are it's not factorable, and I don't want you to spend too much time trying to figure out something that can't be done. Okay, so look at it, see if you can find 2 things that multiply and add. If not, go on. Okay, if we want to see if you can use square roots to solve, again, we want to do that if there's only one x in the equation. And I would by far, you could use the quadratic formula, but using square roots to solve is a lot quicker if there's only one x. Okay? So here's just some examples of types of problems that you would see that you might want to use square roots to solve. All right, completing the square. Again, it takes a little bit more time, but if factoring or taking square roots can't work, then completing the square might be good. Really, you only want to try and do it if the leading term is 1 and b is even. Okay. Otherwise, you're going to run into fractions, and we haven't talked about how to do it if a was not 1. So keep that in mind. And then next, the quadratic formula. When does that work? Always. Downside is there's a lot of stuff. There's a lot of stuff to simplify. I think you probably would agree that you can just plug things in and that's not too bad, but when you have to simplify, sometimes simplifying the discriminant and the denominator and the root and the fraction, lots of things that you can simplify, you could run into mistakes on that. Okay, so it's just like we did for 4.4. We're going to look at these 4 examples and decide which method would be good for here. Okay, and then it says to solve. You'll have something just like this on your test. It won't ask you, it'll say you do not have to solve. If you want to solve to verify or something, you're welcome to do that, but I would maybe save that to the very end if you have time. Okay? All right, so I would always maybe look and see if there's one that you can solve by square roots, because that's really easy to see. So A wouldn't be, B wouldn't be, C wouldn't, but D you can. Also, another thing about your test you should be aware is that you can only use one method once. So here we have the 4 methods, we have 4 problems. I just want you to figure out which method can work, but you can't say, ooh, quadratic formula every time. Okay, so you have to like choose which ones you can use. You can't double use. So here this would be great for solving using square roots, right? So solve using square roots. Why? Because it has 1x, and it's squared. Gosh, my writing is terrible today. Okay, so to solve something like this, again, it's like opposite of PEMDAS. We'd first add or subtract. Next, we'd multiply or divide. And then we would square root. Don't forget the plus or minus. Sorry, I should probably make these bigger for you because you might be on a phone. So we get plus or minus I square roots of 6. So again, we have a negative inside, so we'll make that be I. And we can't simplify the root because it's just 2 and 3, so no groups. Okay, so that wasn't too bad. Again, that doesn't take too much time. So next I'd maybe say, well, which of these could we use the difference of squares? Because that's really easy to find if A is 1 and B is even. So I know that A has A equals 1 and B is even. So I would probably use this, complete the square. Okay, and why does that work? Well, because A equals 1 and B is even. So now we'll do that. Again, to complete the square, we use a little box, and we have an extra box. So x squared, well, that's just x times x, and that's a perfect square. Next would be our negative 10x. But again, to keep it balanced, we need to do half here and half here. And then what completes the square would be negative 5 times negative 5, which is 25. But we don't have 25, it's 6. It needs to be equal to 6. So we need to subtract 19. Okay, and again, a really easy way to do that, especially if you have bigger numbers, is just kind of think this as a little equation. 25 plus what equals 6. So if you just subtract 25, you just get 6 minus 25, and that gives you negative 19. So that's just a little hint if you're ever stuck. Alright, so now we can write down our equation. This is x minus 5 squared, because again that's x minus 5 times x minus 5. And then that's like this whole box. The same thing, it's just writing it as a binomial squared. And then we need to subtract 19 so that the equation is still the same. So we haven't changed what the original equation is. We just put it in a different form. Okay, and then we would, again, kind of do the same thing as when we use square roots to solve. We would first add or subtract. And then we would square root. Don't forget the plus and minus. And then I always try and leave a spot right here so that I can just add 5 to both sides. So x equals 5 plus or minus the square root of 19. Okay, so we've got 2 of the 4 halfway done. Now we need to figure out which of these would be factorable and which one could use the quadratic formula. Now, since quadratic formula works all the time, we should maybe focus more on, say, which one you can factor to. Okay, so like for C, if we try and factor, is there anything that multiplies to 2 and adds to -5? No, no way. So this one would have to use the quadratic formula. Okay. Why? Because the others don't work. Others don't work. So this one we must be able to factor. So let's just see if we can factor it. Alright, so if we factor, make sure we take out the greatest common factor first. So 2x squared minus 9x plus 14. And looks like we'll be able to use the shortcut, which is nice. So it needs to multiply to 14 and add or subtract to give you -9. Okay, so I think that maybe -2 and -7 could work. So we'd have x minus 2 and x minus 7. Okay, and then if you remember, this is like our very first lesson, the zero product property. Okay, that's like we say, if we have a times b equals 0, then either a has to be 0 or b has to be 0. So same sort of thing. This is kind of like our a, this is kind of like our b. So either x minus 2 has got to be equal to 0, or x minus 7's got to be equal to 0, and we can solve. So add 2, we get x equals 2, and here we would have to add 7, and we'd get x equals 7. Okay, so those are our solutions. Okay, so y factor, because you can find the two things that multiply and add. Okay. Alright, so now we'll go back to the quadratic formula. Again, the others doesn't work. Can't use square roots to solve. We can't complete the square because b is odd. It's not factorable. So we'll just need to use the quadratic formula. Oops, sorry. Just going to get rid of that. Oh, dagnabbit, what did I do? Gosh, okay, sorry about that. I don't know what just happened. Okay, looks like it made like a new page. Okay, so quadratic formula. Again, standard form, everything on one side. Check. Identify a, b, and c. A is 1, b is -5, c is 2. And then plug in. So x equals negative b plus or minus the square root of b squared minus 4ac 2 all over 2a. Alright, and then everything from now on is just simplifying. So simplify the discriminant. Just use your calculator for that. Type it in. So I ended up getting 17. So we get negative is a positive, so we get 5 plus or minus the square root of 17 over 2. Next we would simplify the, we already did the denominator. Simplify the root. The square root of 17 can't be simplified, it's prime. And then the fraction can't be simplified either, so this is just our answer. So sometimes the quadratic formula is not too bad. Alright, so there is all of the different types. Again, make sure you're comfortable being able to identify which methods you can use and why. Again, it's going to be very similar like that on your test. Alright, so here are just some other examples of which methods you could use. I'm just going to say don't write quadratic formula unless it's the only thing that you can do. Again, I know you could do all of them using the quadratic formula, and I think even on your homework it might say that you can do it on all of them, but what I really want to focus on is make sure which one can work, or might be the easiest. Okay, so here we're just going to write down what methods would work here. So here I know that complete the square can work. because A is 1 and B is even. Okay, A1, B is even, so we can use complete the square here. Okay, I know these two would be great for completing or using square roots. Okay, to solve, because we have 1x and they're being squared. Okay, next two that we have, let's see. So to figure out if they're factorable, we kind of have to look and see if we can find two things that multiply. So can we find something that multiplies to 24 and adds to negative 11? Again, if you're stuck, write down factor pairs. So that wouldn't work. 2 and 12, that doesn't work. 3 and 8, ooh, that could work. They just both need to be negative, right? So this one would work. So factoring would be good. Okay. And then for f, again, we can't use square roots to solve. We can't complete the square. So we want to check and see, can we find something that multiplies to negative 20 and adds to 5? So for 20 we have 1 and 20. That can't give you 5. 2 and 10 can't give you 5. And 4 and 5 can't give you 5. So this has to be the quadratic formula. Okay. We could check these two and see if they are factorable. I think A is factorable because what multiplies to 8 and adds to negative 6 would be negative 2 and negative 4. So that works as well. Again, you could use quadratic formula for all of them, so that's not really useful to write down for all of them. C, you could factor. I guess maybe it's just this one. This is the difference of squares, so we could factor. What else do we got? Okay, D can't be factored or can use square roots to solve. Okay, so I think that's basically it. So again, you'll have something like that on the homework. You don't need to solve them. Just write down the things that are possible. And again, I know quadratic goes for everything, so again, you could write quadratic for all of them, but make sure what's most important is the ones that aren't quadratic formula, because that's what makes you think. Okay, so here are just some six examples. At the end is just a summary, same sort of thing that we had at the top. Just again, factoring, if you can find the two things that multiply and add within 60 seconds. Square roots to solve. If there's 1x and it's being squared, complete the square if A is 1 and B is even. And the quadratic formula works all the time. You just need to make sure you memorize the formula. Okay? I'm going to go all over all of these. You're welcome to pause, kind of go fast it, go through it, pause and do the ones you want. That would be probably great. Okay, so for number 1, there's only 1x and it's being squared, so I think the easiest is just to solve using square roots. So we would add 25 to both sides. Then we would divide both sides by 4. (25 over 4 can't be simplified, but we can square root both of them. So that would be x plus equals plus or minus 5 over 2. So that's our solutions. Again, we could probably use the difference of squares to solve that as well. Alright, this one again, make sure everything's on one side. So this would give us what? 8. I know this is not factorable. There's nothing that can multiply to 8 and add to 8. So, and we can't use square roots to solve, so complete the square would probably be a good idea. So here we've got our box, and our extra box has to add up to give us 8. So we've got x squared, 4x, 4x. This has got to be 16. And we don't want in 16, we need 8, so we need to subtract 8 from it. So we get x plus 4 times x plus 4 is x plus 4 squared, minus 8 is equal to 0. Probably should have put that there. And then we would use square roots to solve. So add 8 with square root both sides. It's a lot easier to say it than it is to do it. So that gives us plus or minus. So plus or minus 2 square roots of 2. Again, you can do factor trees to simplify the roots. X plus 4. So then the last thing we need to do is subtract 4. Again, I like to leave a spot for that so that I can just box my answer. Alright, we're getting right through it. Okay, same sort of thing, we need to add 3. So we get 15 and 0. Okay, let's see. I don't think it's factorable, so it has to multiply to 30 and adds or subtracts to give us negative 3. So again, for 30 we could do 1 and 30, 2, 15, 3 and 10, 4 and, not 4, 5 and 6. So nothing like that would make that work. So here we're going to have to use the quadratic formula. Here's A, here's B, don't forget the negative though, and C. So x equals negative B, which is negative. So again, we're going to have a double negative, plus or minus the square root of B squared minus 4AC all over 2A. A is 2. Okay, nice thing is if you think that it's not factorable and you use the quadratic formula, typically your answer will be not too bad. So that's kind of a nice thing. But here we'll see what we'll get. So again, double negative gives us a positive, plus or minus the square root. So we need to simplify the discriminant. So negative 3 squared, make sure you use a parenthesis, minus 4 times 2 times 15. So I got negative 111. And I'm fairly certain that that is prime. Yep, can't be simplified. Okay, so the only thing that we can simplify is that negative inside, make it be I. So that's our answer, plus 3 plus or minus I square roots of 111 over 4. Can't simplify the fraction. Okay, I hope I got that right. Alright, next one. Again, everything on one side. I had some people struggle with this. Just remember when you subtract to both sides, you have to be like terms. So we can't actually like combine them, the 2x squared and the negative 10x. We just have to write them on that side. Okay, and then greatest common factor, it looks like 2x. Okay, and then again, when this is factored, we factored out that 2x, so that means we're going to need to use the zero product property. Okay, so that means that either x is got to be equal to 0, so x equals 0, or x minus 5 has got to be equal to 0. So we'd add both sides by 5, and we'd get x equals 5. So those are our two solutions, x equals 0 and 5. Alright, 2 more to go. add 15. So that gives us 40. Okay, so now we just need to figure, is this factorable? Can you multiply to 40 and give you an answer of 6? So let's look at that. So for 40, you got 1 and 40, 2 and 20, that can't give you 6. 4 and 10, ooh, that looks like that could work. So we just need to make sure we got the signs. So I think it would need to be, actually I'll just write this out. It always helps me. So if we did what, negative 10 plus 4? Oh no, that wouldn't work because it needs to be a positive 40. Okay. That both need to be negative, but there's no way you can get both being negative. So, and the other choice would be 8 and 5, 5 and 8. But that doesn't give you a 6 either. So this is not factorable. Okay, but it is a candidate for using the difference of squares. Okay, oops, I probably should erase that because we still need that. Alright, so complete the square. We've got x squared and negative 3x and negative 3x. Okay, we cut that in half. And this would have to be 9. And it's not actually 9, it should be 40. So what does this box need to be? Well, it would have to be 31. Because 9 plus 31 would give us 40. So we've got x minus 3 squared plus 31 is equal to 0. And we just solve. So subtract 31, x minus 3, with square root both sides. Don't forget the plus or minus. So what just happened? X minus 3 equals plus or minus. This will be I square roots of 31. And then we'll add 3. And we get x equals 3 plus or minus I square roots of 31. Last one. So, subtract that over. So 2x squared plus 4x minus 1 equals 0. And then we'll say, well, I don't know, is this factorable? We can't use the difference of squares, or complete the square, sorry, because a is not 1. We can't factor out a 2. Can it multiply to negative 2 and add to 4? No. So I think here we'd have to use the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Alright, so let's simplify this. We got negative 4 plus or minus the square root of, so type out that, get the discriminant. So 4 squared minus 4 times 2 times negative 1. So I got 24 over 4. Next we would simplify the root. So 2 and 12, 2 and 6, 2 and 3. So we got a group of 2's, and then we'd have the 6 would stay inside. And then we'll simplify the fraction. So again, it's the 3 amigos, all 3 or nothing. So 2 goes into all of those. X equals negative 2 plus or minus 1, which you don't need to write, but square root of 6 over 2. Alright, so that's a bunch of examples. Again, I think on your homework you have about that many. If you have questions, let me know. If you're not sure which method to work or to do, just realize that you can always use the quadratic formula, but on the test you will be required to do each of these types of problems. Factoring, complete the square, and the quadratic formula. Alright, we'll see you later, guys.